last podcast we talked about how pressure, volume, and temperature are related to each other and how if one goes up, what happens to the other factor. Now we're actually going to do the math part of this. So in the last podcast, we went over all of the gas laws, Boyle's, Charles, Gay-Lussac's, and then we went over what the combined gas law formula is. And we're really going to be using that formula to solve all of these problems. So let's start with this first problem right here. A gas occupies 473 centimeters cubed at 36 degrees Celsius. Find its volume at 94 degrees Celsius. All right, so the first thing you're going to do in any of these problems is the first thing you're going to do for any of these problems is write down what you know. So what was given to you, and then what do you want? So a gas occupies 473 centimeters cubed. So anytime you see centimeters cubed or liters or milliliters, that is the volume. So we're going to say V1, the initial volume, is equal to 473 centimeters cubed at 36 degrees Celsius. So the first volume we've assigned as 473 centimeters cubed. Well, the temperature that volume is at is this one, so we're going to say the first temperature is 36 degrees Celsius. Now, in the last podcast, and actually the first two podcasts, I said you cannot use Celsius in this. You have to convert this to Kelvin. So let's go ahead and do that right now. So all you need to do to convert to Kelvin is just add 273 to it. Once you do that, you'll have Kelvin. So 36 plus 273 gives me 367 Kelvin. Alright, so the next thing, it says find its volume. So we're looking for a volume. We don't know what the second volume is. After its temperature changes to 94 degrees Celsius. So the temperature went up in this case. And again, it was given in Celsius. Can't have that, so let's go ahead and convert it. So that should be 360. Oh, wow. Okay. This is 367 Kelvin. This is 309. My apologies. So make sure you change that. So the first temperature is 309, not 367. All right, so now we have all of our information. We're looking for volume. So this is volume and temperature. So this is Charles's law. Now, I could plug it into that equation, but rather than trying to just figure out what equation to use, I mean, you do want to be able to know that this is Charles's law, but you can just take the combined gas law and solve using that. So P1 times V1 times T2 is equal to P2 times V2 times T1. So instead of trying to figure out what the formula is that you need to use, well, we're only changing volume and temperature here. Pressure should be held constant in this case. So since pressure is not changing, we're just going to get rid of that. So the formula we're going to use is V1 times T2 is equal to V2 times T1. All right, so now at this point, all we do is plug and chug. So V1 is 473. T2 is 367. Make sure that you're getting the right temperature here, because if you plug in 309, you're not going to get the right answer. V2, we don't know what that is, so we're just going to keep that as the unknown. And T1 is 309. All right, so now at this point, we're just going to solve. So the first thing you want to do is multiply out the 473 and the 367. You guys should have your calculator out and should be doing this too. All right, so that gives you 173,591 is equal to V2 times 309. So now to get V2 by itself, we're just going to divide by 309 on both sides. All right, and then after you do that, your volume should be 561. And I want 3 sig figs, so yeah. 62 centimeters cubed. Since the original volume was given in centimeters cubed, our final volume should also be in centimeters cubed here. All right, so let's do another problem. All right, so a gas occupies 100 milliliters at 150 kilopascals. Find its volume at 200 kilopascals. First thing we're going to do, we're going to write down what we know and what we want. So I'll just write that over here. A gas occupies 100 milliliters, so milliliters, that's volume. So V1 is equal to 100 milliliters at 150 kilopascals. So kilopascals, that's pressure. And since that is the pressure that this volume is at, I'm going to assign it as P1 too. So it's 150 kilopascals. Find its volume. So we are looking for a volume, so I don't know what the volume is here. Second volume. At 200 kilopascals. So P2 is going to be equal to 200 kilopascals. Right? So we have the same unit here. We don't have to worry about temperature. So we don't have to do any conversions here. All right, so we're looking for volume. We're dealing with pressure. So volume and pressure, that is Boyle's law. Boyle's. All right, so looking at your formula, so let's take out the combined gas law formula. P1 times V1 times V2 is equal to P2 times V2 times T1. All right, this is our combined gas law formula. We're looking at only pressure and volume here, so we're assuming the temperature is held constant, so we can get rid of that. So our formula is really this. All right, so let's go ahead and plug everything in now. Pressure is 150 kilopascals. Volume, V1 is 100. P2 is 200, and we do not know what V2 is, so we need to solve. So 150 times 100. Should we plug that in, or just doing this in your head because you can do that? 15000 is equal to 200 times V2. To get V2 by itself, divide by both sides by 200. And you should get 75. And since the first volume is in milliliters, your second volume should also be in milliliters. So your answer, V2, is equal to 75 milliliters. All right, so let's do another one. All right, a gas's pressure is 765 torr at 23 degrees Celsius. What temperature will the pressure be 560 torr? All right, so the first thing it gives us is the pressure. Even if it didn't say pressure here, if you see that torr is given, that is pressure. So our P1 is going to be 765 torr at 23 degrees Celsius, so that's a temperature. And since that is the temperature that this pressure is, it's going to be T1. That's 23 degrees Celsius. All right, we cannot have that. That has to be converted. All right, so 273 plus 23 gives me 296 Kelvin. All right, what temperature, so we are looking for temperature here. We're looking for the second temperature. Will the pressure be 560 torr? All right, so here are known variables, and we're looking for temperature. We're dealing with temperature and pressure here, so we're dealing with Gay-Lussac's law. Alright, so let's look at our combined gas law. That's P1 times V1 times T2 is equal to P2 times V2 times T1. Alright, we're only looking at pressure and temperature here, so we can get rid of the volume and just use this. So it's P1 times T2 is equal to P2 times T1. Now we just have to plug and chug. So P1 is 765 torr. T2 is unknown. Make sure that you're plugging in the right temperature here. And the second pressure is 560 torr. And T1 is 296. So again, you're just plugging and chugging. You need to multiply the 560 and the 296 out. Once you do that, let's see what you get. Alright, you're going to get 165,760. So to get T2 by itself, you need to divide it out. Alright, so T2 should be equal to 226 Kelvin. Alright, so it's given to you in Kelvin. If it wanted Celsius right here, you would have to go back in and subtract it. But since it's not being specific about what unit it wants, we can just leave it in Kelvin. But if it did ask for Celsius, you'd have to go back and convert it. So watch your units when it's asking, or what it's asking for. Alright, let's do another problem. Alright, last one. Gas occupies 7.84 centimeters cubed at 71.8 kilopascals and 25 degrees Celsius. So it looks like we are looking at all variables here. Find its volume at STP. So let's go ahead and dissect this and see what we have. It's given to us. Alright, so a gas occupies 7.84 centimeters cubed. So remember, that's volume. So we're going to say V1 is equal to 7.84 centimeters cubed. At 71.8 kilopascals, that's pressure. Alright, and 25 degrees Celsius, so the temperature is 25 degrees Celsius, but we have to add 273 to that, and we should get 298. Alright, so it says find its volume. So the volume is changing. We don't know what that is. At STP. Well, STP means standard temperature and pressure. And standard temperature is 0 Kelvin. Or I'm sorry, it's 0 degrees Celsius, or 273 kelvins. And standard pressure is 1 atmosphere, or 101.325 kilopascals. So that is our temperature and our pressure. So our T2 is 273 Kelvin. And our P2 is 1 atmosphere, or we can just use 101.325 kilopascals. It's the same thing. And I want to use kilopascals here because that's the unit that I was given up here. Alright, so now I have all of this information. Everything is changing then. So this is not Gay-Lussac's, Charles, or Boyle. This is combined. So since everything is changing here, I don't cross anything out. I'm just going to plug it into this equation. This is my combined gas law. So since nothing is held constant, everything goes in. Alright, so P1 is 71.8 kilopascals. V1 is 7.84. T2 is 273 Kelvin. Remember, watch what you're doing with that temperature. It needs to be the second temperature here. Alright, so P2 is 101.325. And V2 is unknown. We don't know what that is. And T1 is 298. All right, so now we need to simplify and then solve for v. So on this side right here, we're going to multiply everything out. 71.8 times 7.84 times 273 gives me this number right here, 15364, or 74.976 is equal to, again, we need to simplify, times 298. So we're taking 101 and multiplying it by 298 because we can simplify those terms. Times V2. So we need to divide this number out to get V2 by itself. All right, so V2, volume, the second volume, is going to be 5.09, and this is centimeters cubed. Like if you went through with all the units, you'd see what cancels and what's left over, and it's going to end up being centimeters cubed here. All right. So we're going to be doing some practice problems with this. The main thing with these types of problems is make sure you always convert to kelvins. Make sure you're watching where your temperature is going, and make sure you have the correct units. Other than that, it's pretty simple. All right, and I will see you in class.